Hello and you're welcome to Pulumi's Cloud Engineering Summit. My name is Adora and I am very excited to be giving this talk to you today. The title of my talk is Software Engineering in Infrastructure Engineering. And in this talk, I'm going to be talking about how to solve an infrastructure engineering problem that exists by following the software engineering guidelines and principles. But before we get right into that, I would quickly introduce myself. My name is Adora and I am a software engineer at Microsoft Mixed Reality. I am a content creator at Adora Hack. Adora Hack is a blog and YouTube channel that I have created to share about software engineering, share about tech. I'm also the co-founder of Unstack, which is a meetup where all our talks are tailored more to workshops rather than regular talks because we believe that people learn by doing. I'm also the vice president of the VR AR Association Nigeria, which is the Nigerian chapter of the Global VR ARA. And I am here because I want to raise awareness for the technology that is virtual reality, augmented reality, mixed reality in this part of the world. And you can find me on Twitter at Adoranwodo once in a while, just joking, sharing about tech, and sharing about other things that I find interesting. So before we jump right into this, I would want to quickly talk about the fact that this is a cloud engineering summit and I consider myself a cloud engineer. I wrote a book for beginner cloud engineers. So if you are somebody trying to get into cloud engineering, either as a beginner in tech or somebody trying to make a switch from one tech field to another, I wrote this book that I believe will help a lot of people find their footing and would make a lot of cloud concepts make sense. And once you are able to understand the concepts that I've talked about in this book, you will be ready to take on more complicated cloud concepts head on. This book is currently on pre-order for 20% off throughout this month of October, so feel free to get it. So now let's get right into the major business of today. One of the major things that infrastructure as code solves for us when we're talking about IAC, infrastructure as code, infrastructure automation, is configuration drift. What this means is that normally before the inception of infrastructure as code, I would go to, if I have 3 environments, I would go to my development environment and I will start to provision resources on the portal manually. And as I provision, I will document all the steps. And I do that for my staging and for my production environment. So initially, all these environments actually are similar. But as time passes, most times you find out that what happens is if there is an error in production and it is an error that a quick infrastructure change can fix, somebody on the team would go ahead to solve this problem, and that introduces another problem, which is the fact that they would go to the portal and make the infrastructure change. However, when this infrastructure change is made, the 3 environments, development, staging, and production, are no longer similar. So if I want to create a second production environment following what is on my documentation, it's no longer the same. This problem is called configuration drift, and IAC solves this problem because if you have an infrastructure declaration, no matter how many environments you deploy it to, you would always get the same result. And if you want to make any change to your infrastructure, most times you would make it to that infrastructure declaration, and doing that deployment would make the changes in the stated environment, and that keeps your infrastructure configurations always similar. But when we think about it, now we've solved the configuration drift problem with IAC. And as we've started building more complicated solutions on the cloud, as we build larger infrastructure, as we build larger applications on the cloud, sometimes they might involve managing and deploying to multiple locations. For example, if as a small startup or a small business, initially for whatever reason we were not so ambitious and we only had our cloud infrastructure deployed to one region, but as time passed, as the months passed, as the weeks passed, as the days passed, we noticed an increase in traffic. And this increase in traffic was affecting the load on the one server that we had. We might want to have multiple instances of this application, and that might require scaling to multiple regions and having a load balancer that helps us manage the traffic and route to the best or the closest or the freest, depending on whatever metric we use, the most available server in that time. And this sounds very good on paper, especially for backend engineers, especially for networking engineers, even for DevOps engineers. On paper, this sounds very good. We have multiple regions, we have a load balancer, and we're able to route that traffic across multiple regions. However, when we're thinking about it practically, we realize that it is actually a problem maintaining different configurations for different environments, where each environment has multiple instances with varying configurations. For example, let's say we have our development environment deployed to West US, our staging environments deployed to East US, Canary deployed to West Europe, and production deployed to West Europe as well. And initially, because we have just one instance of this application in our different environments, we're fine. But take a look at this next slide, which shows 2 development deployments, one in West US and East US, staging 2 deployments as well, 3 Canary deployments, and 4 production deployments. What this means is that now we have switched to a multi-region scenario where in each environment we have multiple regions. This solves our problem with service availability theoretically. However, this introduces a new problem when it comes to deployments. How do we deploy in a multi-region scenario? How do we fix this? How do we make this easy? We've been giving ISC frameworks like Pulumi as tools for work, but we still have to find a way to creatively solve this problem. And before we go into that, I would want to get some definitions out of the way, and I'll start by defining what a Pulumi stack is. A Pulumi stack is an isolated, independently configurable instance of a Pulumi program. So initially, when I was talking about environments, developments, staging, Canary, production for the single region scenario, one stack can be the development stack. Another stack can be the staging stack. It is a single, independently configurable instance of a Pulumi program. So that's what the stack is. A Pulumi state stores metadata about your infrastructure so that it can manage your cloud resources. And this metadata that is stored is called state. Usually your state is stored as JSON. So it helps you know what resources exist in that infrastructure, what resources depend on the resource, and all of that. And it's that full JSON file that shows you all the important things you need to know about the infrastructure, the metadata like it's called. In many cases, different stacks for a single project would need differing values. For example, if you are working with app service, you may want to have a different tier for your development stack, a tier that is different for production stack. You might want to use a standard tier for development and a premium tier for production. And Pulumi offers a configuration system for managing such differences. Instead of hard coding these differences, you can store and retrieve configuration values using a combination of the CLI and the Pulumi programming model. So now that we have these 3 definitions out of the way, I want to give a final definition, which is software engineering. Like the title of this talk is Software Engineering and Infrastructure Engineering, which is we are using the software engineering process to solve an infrastructure engineering problem. And software engineering is defined as a process of analyzing user requirements and then designing, building, and testing an application which will satisfy these requirements. As you can see in the diagram currently on this slide, we have the different stages in the software engineering process. So there's the requirement stage, designing, developing, testing, and then deploying. So for the requirement stage, the question we want to ask ourselves is, what do we want? But we already know that because that's the problem that we're trying to solve. We want to be able to do multi-stack, multi-region deployments. And for the design stage, we know the problem that we are trying to solve. We know what the requirements are. So the question in this stage typically is, how do we do it? And for this particular problem, there are two ways. The first way is the stack templates, and the second way is independent stacks. My favorite, to be honest, is the stack templates because I like to follow the traditional software engineering rule that says don't repeat yourself. So I like to make the minimal changes where possible. And the stack template allows you to have one template and create multiple copies of that template. And individual configs can be added in the pipeline, and any environment-wide change that you might have happens in one place. So if you need to make changes to every stack that you have deployed in development, instead of making changes to your development stack in West US 2 and making changes to your development stack in West UK and making changes to your development stack in Southeast Asia, you make that environment-wide change in one place. And because all the other things happen in your pipeline, it just works. And this is a code sample to sort of show what doing the stack template entails. So typically, first you would do all your preliminary setups. You would log into Pulumi. So I'm using PowerShell to rename the stack templates to the current stack name, because for me to continue my deployment, I need to have my current stack file in Pulumi when I do a Pulumi up or a Pulumi stack select. So I am going to rename that. So if my stack template is called pulumi.dev.yaml and I have two stacks in my development in two different regions, so let's say I have a pulumi.dev-westus2.yaml and I have a pulumi.dev-eastus2.yaml. I am basically renaming pulumi.dev.yaml to pulumi.dev-westus2.yaml. And after I do this, then I can do a Pulumi stack select and select the regional stack that I need for that environment. I'm adding a -- create flag at the end so that for whatever reason, in case I am trying to select a stack that does not exist because this is a new region that I am just provisioning, then Pulumi would create that stack for me from the very beginning. And then this is me setting individual configs in this stage. So because everything is done in stages, I will deploy my West US2 dev stack in one stage and I will go and deploy my East US2 dev stack in another stage. I can verify what my individual configurations for each stage or for each stack are. Let's say I want to set my region, which is obviously going to be different for each region in that environment because it's happening in different stages. For the East US2 stage, I can set my region as East US2. And for the West US2 stage, I can set my region as West US2. And this is still in context of my development environment. And then I can now move to my staging environment. And let's say I have a UK West stage. I can set my region there as UK West. And I have a South African North stage. I can set my region there as South Africa North. And those are the only things that I have to touch. I'm touching them in the pipeline. Meaning, if I want to make a change for something like app service tier, for a configuration that is going to change across every single instance in the different regions I am deployed to, I'm making that change only in one place, in my pulumi.dev.yaml stack template file. And because because I'm using it in my pipeline and I know how I'm using it, I don't need to worry about making any other change at all. I want to note that to be doing this is like a hack, and that's what I'm sharing, one of the hacks that helped me get by. So I just want to point out that to do this, you have to be very careful so that you don't make any mistakes. So now the next way to do this is independent stacks. This means that you're going to create a stack individually for each environment. In the previous step, you do that, but that happens in your pipeline with the scripts that you write. But in this step, you are going to create them manually, and these stacks are going to be checked into source control. In the previous method that I talked about, these stacks don't get checked into source control. The only thing that gets checked in are the templates. And when the pipeline is running, the scripts recreates the stacks or switches to the stack and uses the template and sets all the other values. But in independent stacks, you are going to create each stack, and each stack file is going to be checked into version control. So what this means, like it's written here already, multiple stacks are created and they're managed independently, and any environment-wide change happens in every stack. So like I said again, going back to my app service example, if I want to change the app service tier for my development environment, and I have 5 development regions: West US 2, East US 2, UK West, South Africa North, and Southeast Asia, as is shown on this slide, I am going to make that environment-wide change to 5 different files. I'm going to make that environment-wide change to 5 different places. So this is what happens in the design step, where you think about how do we creatively make this problem go away? How do we design a way to do CI/CD for multiple regions in a way that works for multiple environments as well, while maintaining all our configurations? So your design step answers the how. And once you've answered the how in your design step, then it's time for your development step. So you need to write all your infrastructure deployment code, all the PowerShell scripts, everything you need to do, all your build scripts. You have to go and write all of them. And then the next thing that happens is that you go and test what you've done to be sure that it actually works. I know a lot of people skip this testing step, and I would highly recommend that you not, because it boosts confidence and it is very helpful long term to know that the code you are writing is code that actually works and not code that gets checked into production and breaks the entire system. And then after that, you do your checking in, you deploy your infrastructure changes to the cloud, and see how you can now do multi-region, multi-environment deployments in your CI/CD pipeline. Thank you for watching this talk. I hope you have a great day, and I hope you enjoy every other talk from every other speaker.